Now let's take a crack at number 2 on the practice final. So here is the question. We just have a function, t times sine t plus 2, and we're supposed to do these two things. Okay, so one is give the equation for the line tangent to f of t at this point. So very easy, because we just use the point-slope form of a line, right? Point-slope form. So we're going to have some point, which is this point, right? I can easily figure out what numbers these are. In fact, if I plug in 2 pi into this, what am I going to get? Sine of 2 pi is 0, so I'm going to get 2 pi times 2 is 4 pi. So there's just going to be a point in the plane 2 pi 4 pi. And what do I want to do? That's point slop, isn't it? Sorry. And so now I want to just find the slope, okay? So if you have a point and you know the slope of a line going through it, then that tells you everything about the line. And you know, the equation for figuring these things out is that the equation for the line is y minus y1 equals m times x minus x1, where these things at y1 and x1 are the given point, right? This given point. And then you plug in this, plug in the slope if you know the slope, and what's left is an equation in y and x, and it describes this line that goes through that point with that slope. Alright, so what does calculus have to do with this? It's because the slope of the line through this point is exactly f prime of 2 pi, right? So the slope, m, is just going to be f prime of 2 pi. So let's figure out what that is. So f prime of t, I use the product rule. This gives me sine t plus 2 plus, now the t stays there, and what happens to the sine? It becomes cosine t. Okay, alright, and so to solve for m, I just do f prime of 2 pi, and let me see what happens. Sine of 2 pi is 0, and 2 doesn't care about the input. And what happens here, I get 2 pi times cosine of 2 pi, and cosine of 2 pi is 1. So this is it, alright? And so now I just have to plug everything in. Let's see. So the equation for the line, the answer to part A is going to be y minus, what is y1? Y, it's this coordinate of the given point, so it's y minus 4 pi is equal to, and now I have the slope, 2 plus 2 pi, times x, and you can see the given point here, and the x-coordinate is 2 pi, so it's going to look like this. And now, dun, da, 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 you just have to move the thing over and you're done. So it's 4 pi plus 2 pi times x minus 2 pi. And I'm just going to leave it like that. And I'll put a red box around it. Okay, so this is the answer for part A. Now, what's going on here with part B? We have to find a value that witnesses the mean value theorem. So let me remind you what the mean value theorem says. Let me draw there's a y-axis and an x-axis. And whoa, it's not much of an x-axis. Here's an x-axis. And the function is going to be kind of bouncing along here, something like this. And what we're going to do is we're going to look on this interval from minus 2 pi to 2 pi. So let's say it's like right here is going to be my 2 pi, and sorry, my negative pi over 2, and over here is going to be, my pi over 2. And we're going to have some line that connects these two things, and then what we're going to be hunting for is just at least one value c, so that the tangent line at c is parallel to the red thing, right? And I'm not really being very successful in drawing it, but yeah. So, it's not really going to look like this. I mean, where did these curves come from? Just my shaky hand, right? So, but basically what we're doing is looking for these values, like this value here would work, this value c, where the tangent line is parallel to the red secant line, c. Okay. Alright, so what are we going to do? We need to, first of all, find the slope of this red line, right? We can't solve for the slope of f prime. We can't solve for, what we want to solve is f prime of c equals m, right? And we can't solve that unless we know what m is. So what is m? It's just rise over run, right? Rise over run. And so what is this? It's going to be f of pi over 2 minus f of minus pi over 2. Okay, so that's the rise. And what's the run? The run is just pi, right? And okay, so what comes out when we do this? So we're plugging these things into the original function. And here it is. It's so shy, hiding up there. And what happens when we plug in pi over 2? You get pi over 2. And sine of pi over 2 is 1, so it's going to be equal to 3 pi over 2. Alright, and so, okay, so I've got 3 pi over 2 on top here, and I take away what happens when I plug in minus pi over 2. I'm going to have minus pi over 2, and then sine of minus pi over 2 is minus 1. So what is this going to be? This is going to be minus pi over 2. Okay, alright. So I've got, this becomes a plus pi over 2. And on the bottom, I've just got pi. And let's see what happens now. So when I put these two things together, I just get 2 pi. Over pi is just 2. Holy smokes, that's such a simple, nice number. And so what should I do now? Well, I want to find this point C where, f prime of C is equal to, now I know that this is 2, right? And so where did f prime go? Here's f prime. So maybe I can even steal it. Let's see if I can copy this and move it down to where come on down, buddy. Move it down here instead of, okay. Alright. So, great. So what I want to solve is the equation sine t plus 2 plus t cosine t is equal to 2. Alright. So one thing I can do is obliterate these 2's. They cancel each other. And what I get then is sine t plus t cosine t is equal to 0. Alright, and so there's a lot of t's there, which is a little bit scary, but if you just think about it, you know a solution to this, right? So many t's. What happens when you plug in something normal for a trig function, like pi or 0 or something? You should try those things. So what happens if I plug in pi? Let's say I get sine is 0, cosine is minus 1. Doesn't work. But you can see that if you plug in 0, it does work. What happens if you plug in 0? Get sine of 0 plus 0 times cosine 0. Okay, and what is this? It's 0 plus 0 times 1, and this is in fact equal to 0 plus 0, which is 0. Okay, so, alright, so t equals 0 is a solution. And we are done, because now we know that this c here is actually, should be over at the origin. So 0 is going to be the place that works. And alright, so let me just officially write it here. The value c that witnesses the mean value theorem on this interval is c equals 0.